Next up, we're going to be condensing logs. And there's 3 rules for condensing logs. They're really the opposite of the 3 rules we talked about for expanding. So our first one is the product rule, which says that if we have log base a of x plus log base a of y, if we want to condense them into one logarithm, the key thing here is that it goes from having 2 logs to just 1 log, as long as they have the same base, which they do, log base a, and then addition means that we're going to multiply. So that just becomes xy. Our quotient rule is if we have a log base a of x minus log base a of y, we're going to condense those by writing them as one logarithm. But instead, when we are subtracting, we're going to be dividing them. So x and y get divided. And the last rule is the power rule. And the way the power rule works is if you have something as a coefficient in front of your log, then to condense it, we don't want any coefficients. We want everything to be written as one log term. That is log base a of x to the n power. Now we're going to do a few examples to condense some logarithms. So our first one here, again, we'll start out easy. We've got 2 log to the 5th power plus log of x. So the first thing we need to do is move that coefficient on our 5, log of 5 squared plus log of x. Well, 5 squared is 25, so log of 25 plus log of x makes that multiplication log of 25x. Next one we'll take a look at. We have log base 4 of x minus 3 log base 4 of x minus 1. What actually happens here is this, I'm going to move the 3 as that exponent first, and I go backwards. Log base 4 of x minus log base 4 of x minus 1 quantity cubed now. And then we'll combine these as, since this is subtraction, it'll become division. So log base 4 of x over x minus 1 quantity cubed. Now I could multiply this out, and I'm going to, but you could if you wanted to keep going. Nothing's going to simplify, so it's not necessary to keep doing that. All right, let's take a look at another example. If I have 5 log base 3 of x plus 1/2 log base 3 of y, then I'm going to move my 5 over on my x, so log base 3 of x to the 5th power plus log base 3 of y to the 1/2 power. And then I want to remember my goal is to write that as one logarithm at the end. So this addition tells me I'm going to be multiplying, so log base 3 of x to the 5th and the square root of y. When we're condensing, we want to get rid of those fractional exponents, change those into roots whenever possible. So that is our answer there. Let's do another one, maybe one a little crazier. All right, so if I have 3/5, 3/5 natural log of x minus 7 natural log of y minus 4 natural log of z. Now they're all natural logs, so we all have the base of e. We're going to move all those exponents over, so natural log of x to the 3/5 minus natural log of y to the 7th minus natural log of z to the 4th. So this doesn't mean we're going to have a fraction over a fraction. This means that this is in the denominator and this is also in the denominator. So I have natural log of x to the 3/5 over y to the 7th and z to the 4th. The last thing I need to take care of is this fractional exponent. So the 3 is x to the 3rd, but the root part is the denominator. So I have natural log of x cubed with the 5th root being taken of it, y to the 7th, z to the 4th. And that all is natural log with a base of e there. Let's do one more crazy one. All right, example 5 here. We've got a 4 way out in front, natural log of x plus natural log of x plus 5, close the bracket there, minus 2 natural log of x minus 5. Yeah, let's go with that. All right. So I'm going to try to simplify this into one logarithm first, then I'm going to put the 4 on that term. So I'm going to keep this 4 out here for right now. And I'm actually going to multiply these two together. So x times x plus 5. So if I have natural log of x times x plus 5, I'm going to need to multiply that through and distribute that x to both terms. And I've got my minus 2 natural log of x minus 5. So I have my 4 still on the outside, natural log of x squared plus 5x, close that, and then minus natural log of x minus 5, and we're going to square that, because that 2 is coming as an exponent. My coefficients become exponents. Now I'm ready to give that 4 to my what's left here, so natural log of x squared plus 5x to the 4th power, minus natural log of x minus 5 to the 2nd power. And the subtraction sign is going to let me move this into one natural log with x squared plus 5x to the 4th power over x minus 5 squared. And that is all this entire natural log problem. Looks really crazy, I know. Make sure that your natural log is not on the numerator of your fraction. It's the natural log of this. So just be clear that that's not a part of your fraction. That is outside, and you're taking the natural log of this equation.